All right. Do you see my screen?
Yes, yes, John.
Yes. One of my monitors is not working, so instead of fixing it, I thought I would work with two. I have three screens. Yes. So, hi everyone. Thank you so much for inviting me on your community to speak today. And I apologize that we had to reschedule last time. I saw that. There was a conflict with my other events here in Sweden. So I'm glad that you're patient in waiting for this session. And today I will be sharing about Azure Durable Functions for cloud developers. And it's a pleasure and honor to be here speaking with you virtually from Sweden. So before I start, I want to share about myself. So I'm Jonah Andersson. I work as a software engineer consultant or developer, and I also do some DevOps in my IT consulting job. So that's what I do on my daytime job on Mondays to Fridays. And then partially, I also teach Azure, especially the AC 900, the fundamentals, certifications, and also AC 204, the Developer Associate exam as a Microsoft certified trainer. And I do that internally in my company, which is called Forefront Consulting in Sweden. And I live in Sweden in a city nearby outside the city, Sundsvall, which is mid north of Sweden. And I've been remote working since the pandemic started, and I'm enjoying the remote and hybrid working way of what we've been doing. But yeah, so I'm also a Microsoft MVP for Azure. So sometimes you see me speaking a lot about Azure technologies or writing about it. And if I have spare time, I mentor young women in tech or in any ages and help them in case they want to have some guidance in how it works working in a tech, especially if you're a woman or lady programmer working in the branch. So I'm trying to mentor and do make a difference that way outside my work. And I am also writing my first book called, as you see here, it's called Learning Microsoft Azure, that you can check out the early release on the QR code here. And of course, I'm also a community leader, an inclusive one, which means that we welcome beginners of all races, of all backgrounds to speak and share their knowledge in our community. And it's English, even if it's called Azure User Group Sweden, and it's virtual because I wanted to create that type of community. So you can also join us. You can find us on a Meetup as well. So that's about me. A lot of like small or different roles I do, but I'm enjoying what I do for the community, just like what you do as well in this group. So today my plan is to go through what serverless is. I think you mentioned like all of you are mostly .NET developers like me, and you almost are Azure professionals that work with Azure daily. So that's great. I hope this session won't be too beginners for you, but those that are new, it will be something useful and learnful at least. So I will be sharing about serverless and the different serverless technology in Azure, Azure functions, what it is, just a brief one overview, durable functions, and then the different application patterns that you need to know in Azure durable functions, which help solves different kinds of complex workflows or use case scenarios. And then if our time permits, I we will see. If our time permits, I can show you a demo or a template that I created in one of a small project I had, and recommended learning resources if you want to deep dive or learn more about this technology in Azure. So before I start, I want to share with you about this dining philosophers problem. I'm not sure if some of you have heard of it, but I first encountered the dining philosophers problem when I was studying concurrency in Java because, before I started working as an IT consultant, I studied computer science and then .NET development here in Sweden and then Java development. So of course you have to learn this stuff. But I first encountered about the dining philosophers problem, which looks like this. So there were like five philosophers and five chopsticks if they were Chinese, of course, and or if we do it the Asian way, because I'm originally from the Philippines, we do have a fork and a spoon on the side. We need both in order to eat, of course, right? So the dining philosophers problem basically tells us about the problems like deadlock, which means that if each of the philosophers are gonna pick their like fork and spoon beside them left to right, which means that all those philosophers are not able to eat because there's a problem of deadlock there. And then of course if they're not able to eat, which means that their dinner is messed up, they're gonna starve, and maybe they're gonna end up fighting also because they really want to eat that good food in the table, but it's not matching. So if you work with development, you know that deadlock is actually hard to debug, especially in our applications, and it's especially if it's an existing applications that we need to fix, we need to maintain, and you don't know what's going on. Maybe it's not well documented. So deadlock problems and concurrency problem it can be challenging for us developers to solve, but there are solutions for that. For me, on my side, I believe, especially if you have applications that work with that is integrated with Azure or hosted in Azure. Usually, concurrency problems can be solved, of course, with the .NET features that we have already in our libraries and SDK. But you can also solve concurrency problems in your architecture and also how you design your services or functionality in your apps. So concurrency problems, racing conditions, deadlocks can be solved with serverless technologies like Azure Functions in the cloud. So, what is really serverless? So here is a funny GIF or memes, I think they call it. I found online, and this is we have a credit to the person who made this. And this is a very funny one. One person was asking, why are you throwing out the servers? And then the other one, because the boss said that we're gonna be switching to serverless. So what is really serverless? I mean, is it replacing the all on-premise or traditional servers that we have? Or it is something else. So serverless is actually a super marketed or cliche word that is often used all over the internet, but it is actually it just basically means that there's an abstraction of servers or infrastructures. Instead of having it on premise, then you abstract it and you have it in the cloud, and the cloud is taking care of the infrastructure or the servers for us, and which means that we focus into our development, which results to developer productivity. And also you have this mindset of event driven, which means that you break your logic that you want to do, the functionality that you want to do, into functions. For example, you might need a feature that you will be able to add a user to your UI, and then you want to like save it to a Cosmos DB database. That can be one logic that you can break into function, or something like microservices as well. And then serverless also allows us to automate some processes because of the triggers, and it's event driven. It's pay as you go, which means that serverless are also commonly used to save some money in terms of event driven types of processes in the applications. Integration and auto scaling is also one feature of serverless. So here in Sweden, we have this term called Fika. So even though I'm originally from the Philippines and I live here 11 years now, I've kind of adopted the culture, and we have this Fika, which basically mean is just like you're having coffee with your family, friends, or colleagues on your break time, and then you just don't do anything else. Just do drink some coffee, and then you have a good conversation. But my point in this PowerPoint actually is to show you the comparison, the Fika way, Swedish Fika way, comparison of monolithic to serverless. So, for example, monolith is like a layered cake. You know how it works. The traditional ones, we have the layer for you have everything in one place, layer for data, your logic, business logic, and other stuff. And then there's also microservices, which services that are isolated based on their functionality and purpose, just like the cupcakes. And then we also have containers, which is a pretty big thing today, a lot alongside with serverless, in which you have everything in one box. It's easy to carry, it's light, it's easy to run, it's not as heavy as virtual machines. So that's also, it's just like you can compare maybe one box of containers as one box of cookies with different sorts of it. Everything is in it. And the monolithic is like a big virtual machines that you have to carry with you when you're riding on the bus or a train, for example. So that's the comparison of that. And serverless, they are like light and easy to fix. I mean, easy to create, and it's easy to implement in existing applications, even new ones. And they're like candies that it's easy. It's easy to add the logic in there and break into it. So those are the comparison. But the point here is that the more you go to the left, which is the monolithic, this means that you have more control because you have access to the infrastructure, the databases, database server, and you have to take care of that. But that means that you are less productive because you have to maintain everything, make sure everything is up and running, aside from the app development. And as we go to the right, for example, if we choose containers and serverless, we gain more productivity. The control that we used to have in traditional like application development, we put it we take it back, and we let the cloud provider like Azure, for example, take care of it for us. And that's in relation also to what we have with the cloud provider, which is this shared responsibility model, depending on the type of deployment, models that you choose: infrastructure as a service, PaaS, SaaS, or data as a service. So these are the point of this comparison. So why serverless in Azure is because, of course, it help increase our productivity. We don't we abstract the hassles of maintaining the servers, and then we can build and deploy quickly as well. And then when you're able to build and deploy quicker, that also boosts our team performance, which means that the business side, the development side, all of the teams in the IT project will be able to collaborate more with these smart tools and modern tools that we have available in Azure. And also, if all is working fine with our team, then that means that we improve our organization's impact, not just internally, but also how the organization is creating impact outside when it comes to modernization of our apps and digitalization, and even the TCO and even security in Azure. So in Azure, there are actually a lot of services. I don't want to dig deeper to them right now because we're focusing on Azure Functions, but there are actually not just Azure serverless in the compute level, like Azure Functions, but there are also serverless workflows and integrations, for example, in without writing a code, which you can actually find and you make use of with, for example, Azure Logic apps. And then when it comes to containers, there are actually server Azure container apps right now that recently, I think last year, several months ago, was released. And then there's also with Azure SQL, you can also have serverless or pay-as-you-go consumption plan. And also Azure Cosmos DB has the option for you to do serverless as well. And Azure Monitor is widely used for monitoring, even with serverless. And IoT services, AI, machine learning services can well be integrated with other serverless solutions in Azure. So what is Azure Functions? I think most of you have worked with it in your
Jonah,
jobs. Oh, yes.
may I interrupt and ask a question on the
Yeah,
previous
sure.
slide?
Yeah,
Okay,
sure.
so when you say serverless database, Azure SQL database serverless, are there, because what we have already implemented is Azure SQL database, but I was not sure if there is an option for serverless as well. So there are two options. One is this, and the other one, which is non-serverless. Is that so, or you have just explicitly mentioned that in brackets, so it is clear that this one is serverless?
Yeah, there is an option in Azure SQL that you can set it as pay as you go model, which that's why I indicated serverless brackets in it. Does that answer your question if I understood it
Yeah,
correctly?
that correct. That
Yeah.
does. So it's serverless only, pay as you go. We are using that. Okay, thanks.
Yeah, yeah, that's right. And Cosmos DB has that as well. Thank you. Okay, thanks for the question. So, yeah, so Azure Functions, I believe most of you, if you're working with dev with Azure, you are familiar what it is. So it's part of the serverless compute service in Azure. As mentioned, it's event driven. You focus on logic, you're productive, and you can integrate it with other services. But basically, it's actually our code. And then the events that we have, it can be a trigger from a Cosmos DB. Works, for example, you have a new data coming in, and then a function can be triggered, or it can be an Azure storage, blob storage triggered, and then you have your data in it, and then you process it further. So that is Azure Functions, code, logic, and then your data and your events. So Azure Durable Functions is a bit special. It's actually not a what do you call it? A competition, if you call it that in that word. It is actually the bigger sister of Azure Functions. So Azure Durable Functions is an extension of Azure Functions. So what's special about it is that it allows us to write stateful workflows or even stateful entities in serverless environments. And stateful means that it manages or checkpoints the state or restart the state for us, which is a normal or standard Azure function can't do. And the reason behind durable function extensions is working like that. It's taking care of the state for us. It's because of the framework. I believe this is open source. It's called the Durable Task Framework, and you can check it out if you want to see the source code. You can go to that repo link there, and you are able to code this one with the languages that we commonly use, like C Sharp, JavaScript, Python, F Sharp, and even PowerShell. So basically, Azure functions are stateless by default, and then durable functions are designed to be stateful for both workflows and stateful entities. And then there are different types that you need to know when you're designing your durable orchestration with durable functions. So you would need, for example, client functions. Client functions are the starting point of the entire durable orchestration, and it uses the trigger entity binding in it. So this one is typically what you call, for example, if you go to VS Code or Visual Studio, And then there's a template actually for a durable function. And usually you get all these types of functions. So the client functions is usually your starting point your trigger. So you have, for example, your Azure Blob trigger here, or your service bus trigger. So that's your client function. And then the client function kickstarts the orchestrator function. And the orchestrator function is actually where you write your workflow. You design what you want to do with the activity functions that you set. So actually, activity functions are a unit of tasks that you want to do, which means, like, for example, if you have an application that saves a data to a Cosmos DB, and then you want maybe to have a Cosmos DB trigger, which is considered as client function, and that Cosmos DB trigger kickstarts your orchestration, and in here you write your workflow, uh, and then you do your task depending on the patterns or flow that you want. And this entire process from here to here are actually like stateful, which means it doesn't lose its state, and it runs as long as how you want it, or you control it. And there's also a different type called entity functions. And this is a bit of separate. This is when you want to do stateful entities in .NET, for example. So that is something, stateful entities is something that very special, that you can deeper in a separate, like like tutorials, because it's a big one, and it's interesting one if you're going to work with entities. So um, Orchestrator is a special one because this is where, as developers, we write our workflows. So the orchestrator is our friend, but he or she is strict. Why is that? Because he or she is deterministic, which means that it expects the same results all the time, and the entire workflow will be replayed. So when we write our workflow, it is important that we follow the code constraints recommendation of Microsoft or Azure Functions for this, and you can read more about deterministic API if you want to learn more what's behind it. So this is how it looks. So when you have an orchestrator using durable functions, so you have control. This is your workflow, and then you have control what your tasks are doing, as based on how you want to do it in your requirements. And then this is something without an orchestrator or workflow. As you can see, you can consider this as isolated Azure functions. They might be talking to each other, but if something goes wrong with this, it might affect the other one. It depends on how you did your logic. But I believe that it's more safe proof, especially if you want to keep your state, to use durable functions. And the scenario is different. What to use for what is actually depending on the use case that you're trying to solve with our business requirements. So the constraints, I mentioned about constraints and the orchestrator, because the orchestrator is deterministic. So there are constraints or do's and don'ts. Like, for example, the don'ts are, here are the list. Like, example, since deterministic means it expects the same result, this means that you cannot have random round numbers like GUIDs. And then configurations, instead of, it's not recommended to put it on the orchestrator function. It's best to do it on, for example, in the activity functions instead. You have your isolated configurations there. And then blocking APIs is not also recommended to be in the orchestrator function. And infinite loop, of course, not there. Can you imagine if you're still beginner and still starting to play around with durable functions? It's like pay as you go, and then by accident added an infinite loop or forever loop in your workflow, and your workflow will be replayed. So there's a risk that because of that small tiny mistake, you might end up having a big or huge amount to pay in your Azure bill or subscription. So we can be more careful of that. But what you can do instead is there's a method through the context, and this method is different depending on the language that you're using. But in .NET, I know that if you do context.createNew, this is where you can repeat the same process if you really want to call another sub-orchestrator or another activity as well. And the normal .NET current datetime is not actually recommended to use in the orchestrator. What you can do is you can use the context and then use the current UTC datetime. And this is specific to .NET. It might be others in other languages. So if you want to learn more about this constraints, this is just like a few of them. You can go to this link or just search durable functions code constraints, and you'll see a big list that Microsoft recommends for the do's and the don'ts. So now we need to go through the application patterns, which is very good to learn, especially if you're trying to decide what is a good workflow or patterns to use in different use cases. So we have actually about 6 documented in Microsoft Docs. So there's the function chaining, fan out, fan in, as async HTTP API, the monitor pattern, the human interaction pattern, and then the aggregator pattern, which is used for stateful entities. And then the function chaining is actually, as you see, it describes it pretty well. It's a chain of functions, which means that the first functions is going to pass in, has to pass in the parameter or data to the next one, and then to function 2 to the third function, and so on and so forth. So it actually executes the functions in sequence in a particular order, like a chain. So if function 1 is a required input of function 2 as you go along. So function chaining in action, I have an example of this at the end. Maybe I won't be able to show the demo code because of the time, but I can share the repo later on. But this is function chaining in action. So for example, you have Cosmos DB maybe trigger, and when a data is added, you have the orchestration, the durable workflow. So when it's triggered, that event is triggered, the orchestrator is started. So your first activity gets scheduled. And then when activity 1 is scheduled, the orchestrator sleeps. And then activity 1 is done, it's going to sleep again. Activity 2 then is scheduled, and then orchestrator sleeps again. Activity 2 is done, and then the orchestration is completed. This is considering you only have 2 activities that you want to perform after your Cosmos DB is triggered. So as you can see here, this entire process will be replayed, especially every time the Cosmos DB gets triggered or that gets kickstarted. So it keeps on going. It's stateful, and as you notice here, the orchestration gets awakened here and then sleeps. It sleeps, wake up and sleep. So the good thing when the orchestrator sleeps, like it can be a sleepyhead, but it's actually good because this means that you, if you're in a consumption model or pricing model, for example, this means that when the orchestrator sleeps, you're only paying for the instances when Azure function or your activity is running. You don't have to pay for activity 1 to 5 if your activity 3 is the only one that needs to run in production or needs to be running active. So the orchestrator can be sleepyhead, but it is good for us. So this is how it looks in the code. This is an example I borrowed from Microsoft Docs. So in C Sharp, you see it's a sequence of function. This is actually the boilerplate or template that you get usually when you create one in VS Code and Visual Studio. So it's pretty simple. You have a sequence of hello with strings in it, and then it returns the output as a chain, as a sequence when everything is done. And then we also have another pattern called fan out, fan in, which is which means that you actually execute multiple functions in parallel, and then you aggregate the result as one. So fan out, fan in, and there are certain scenarios that you would need to do this in a real business case. If you're going to do this in, for example, in normal Azure functions, you would have to kind of like if it's stateless, I mean, you would have to keep track of the state of each of this, maybe in a queue, in order to aggregate them, and it's pretty hard to do without durable functions. So this is a good scenario if you have something similar that can be solved with this. For example, several list of customers that wants to receive emails or something parallel tasks that you want to do. You want probably to, when an order is processed, you probably want to send an email to the customer, and you also want at the same time inform the order processing people or team. And then maybe here you want to create or do something else, like send a notice to those that are preparing the order. But for example, if it's a store online. So you can do things in parallel, and then you aggregate the result later on, depending on what you want to process. So an example of this in Microsoft's template is actually this one. It's like backing up a site content. So here we have a function name called backup site content, and then you have your durable context. So you're trying to get the directory of the root directory, get it as a string, and then you check if it's null or not, and then you actually try to get your files, all files in the root directory, and you're gonna have it in the loop and save it in your blob, copy to blob. And then when everything is done, that's when the fan in comes in. You usually use the method called when all, task when all, in the context, and then you return the result. And this one, it's a very simple one. It's just returning the bytes, the size of it. And then the next one is the async HTTP API pattern, which is used to actually solve problems with long-running operations, especially with internal, external clients and URLs. So usually, you can use the HTTP endpoint trigger for a long-running action, and then you can redirect a client to a status endpoint. And I have a simple example here. This is a stateful way to check if my website is available. So here I have a function called check if my website is available. I have an orchestration trigger, a context, durable context. And in the try catch block, I have a URL. That's my website, my blog website. And then I create the instance of durable HTTP response. This is what you use for this pattern. And then through the context, I can use the method call HTTP async, passed in your HTTP method. For me, in my case, it's get, and then your endpoint. For my case, it's just my website, so my URL, but it can be your API endpoint or whatever endpoint that you need to call that needs to be long running. And then I do in my if conditions, if I'm getting a good status code, I'll process it. Otherwise, I'll throw an error or handle those error in my code. This is .NET. And and then the next pattern that we have is the monitor pattern. So it's as it is called, it is used for long running or recurring processes. Like, for example, if you need to monitor something, like, for example, a periodic job cleanup in your workflow. So this example that you have in the code is like here you have monitor job status, you have your durable orchestration context, you have your like variables here, and then in your while loop you actually create like an expiration time. And then through your while you're checking the expiration time, you actually check on the status of your job. If it's completed, then you're gonna do alert. Otherwise, the orchestration actually keeps on. I mean, it will sleep until the next job or monitoring needs to be done. So that's the simple example of how you would implement a monitor pattern. And then the human interaction is actually a good pattern to use if you require human approval. For example, if you have maybe a verification documents, or in a business case that wants to be approved by a person, you can actually use the human interaction pattern. And then here you have, for example, if the person is the human person is approved the process, then you can call the activity called process approval. Otherwise, using a durable timer alongside with that check for external event, you can escalate the process if maybe that person that's supposed to be processing the documents or approving it might be on vacation or on a weekend. So you can set a timer alongside with it. So this is the approval workflow example. So I'm highlighted the most important one to take note. So there's like this durable timeout. So you can use that using the method create timer. So you set your durable timeout. For this example, it has like 72 hours like a timeout. So if the external event, which is the approval event, this is coming from a person. So the approval event is actually calling a method approval event, which checks if the document is approved by a person externally, then it's gonna do that. Otherwise, the timeout or the durable timeout takes over that workflow, depending on what you set in here. And then you call escalate or do something else, send an email maybe, or forward to another person who can process it. And then the last pattern is actually the aggregator pattern, which is commonly used for stateful entities. And you're gonna use aggregator pattern if you want, for example, aggregate entities or event data at over a period of time. And this data that's coming in, or entities, they can be coming from different types of resources and can come in anytime. And this is not easy to do if your Azure function is not stateful. So that's why Microsoft have created this extension for this specific purpose as well. If you want to work with entities that needs to be stateful. And this is an example of how it looks by code. I don't have a code example for this, but you see that it uses the durable entity context instead of the client functions. And then it also has several functions, for example, like if you're having for example, if you want to get the state of your entity and you want to get the value, you can actually use get input in the type of data type that you're trying to retrieve in that entity. And then here also you see that through your durable entity client, you can use a method, for example, signal entity sync, and then the ID of your entity, the method, and then the parameter that you passed in, like the amount. So there's a lot of this. It could be another deep dive, a separate one, but you can read more about this. This is very good feature of durable functions. Just search durable entities and you'll be able to find some tutorials and quick starts there as well. And then those are the 6 patterns. And then, of course, they are the common ones that can help solve our complex problems depending on the scenario. But you can actually create different types of variations of your patterns. So durable functions allow us developers to actually create sub-orchestration within an orchestration. Currently, as far as I know, it's only supported in .NET, so that's good for us, .NET developers, and then JavaScript and Python. Not yet in PowerShell, but as you see here, the normal durable durable orchestration usually have a client function, an orchestrator, and activities. But as you see here in the middle, there's actually a sub-orchestration orchestrator in between, which means that in your orchestrator, you can have a lot of sub-orchestrator in it, and then you have your activity spread out in it. So this is useful if you know that you're gonna need it. I don't have a specific example, but it's kind of like microservices in a way, but in serverless in durable functions. So for example, maybe this sub-orchestration will handle user management related tasks. And maybe this next sub-orchestrator needs to handle billing related or order management related tasks here. So this is something that you can make use of as well if you need to in your apps. And this is how it looks in the code. This is the context, and you can call this as your orchestrator function. And what this does in this example is trying to provision new devices. And so here you have a list of strings, getting the device ID. This is another activity function. And then you have a for each loop in here that loops through each device. And in each device, you're going to have a subtask or a sub-orchestrator. So here you have a task, and it's calling the sub-orchestrator or another orchestrator with functions in it or activities in it. And it's going to do its tasks separately. And then it's doing this combination of fan out, fan in pattern that when all of those devices is done, executed all the sub-orchestration, then it's going to like aggregate the result or do something else. So in your orchestrator, you can combine all these patterns that you have learned so far. And when it comes to development, I think this is pretty beginner for you since you know the tools already. If you work with Azure Functions, there's like you can do it with the Cloud Shell in the Azure portal if you're still like not comfortable with the command lines. You can also get started using Visual Studio, VS Code, and one thing that you need to know is that, or one great feature of Azure Functions is that you can develop it locally, and you can debug it locally, and it can talk to your resources in Azure and even APIs externally. I mean, you can work locally, and in order to do that, you would need to use the Azure Function Core tools, the latest version. And usually I myself make use of some like tools like Postman, Azure Storage Explorer, And also there's a good extension in VS Code called a REST client that you don't actually need Postman or your web browser to call a request to an API, for example, or an HTTP do an HTTP request. You can actually just do it in your own code and call that using that REST client extension. And then you can code in different languages that's supported. And then you can also do full stack development with Azure Functions using Azure Static Web Apps, which supports other like front end frameworks like React, Blazor, and a lot more. And if you already have your own functions or Azure functions in the production, then you actually have the option for two ways to implement it in your Azure Static Web Apps. You can either bring your own functions hosted in a separate resource group, or you can actually use the API built in, the API support built in when you create your Azure Static Web Apps libraries or project. And when it comes to debugging or finding out what's going on, I would like to share about this orchestration details that's happening behind. So it's saved in the Azure storage. So you cannot create an Azure functions without linking it to your Azure storage. So behind it, you're actually having task tables that you can check out with your storage. And there are, for example, if something stops or something breaks and you don't know what's going on, these are the links or orchestration details that you would need to know for instance management, so you know how to control it. So the ID you always get every time you start an instance in your orchestration. And then there's also the URL of the instance. If there's also the raise event URL, the terminate URL, if you want to terminate it by force. If it's something uncontrollable, you can use this URL to terminate. And then the purge history and even the restart if you want to manually restart your URL. And this URL that you see here, this is a local host, as you can see, but you can be something that's hosted already in Azure. This is something that's good to know because you can reuse it actually by code if you need to control the instance or the state of your workflow. And the next one, coding durable functions, just good tips to know. Like, for example, app insights, you can implement it. When you already have you're developing with your app function app already in production, it's good to have conscious versioning, side-by-side deployment, and deployment with breaking chains are good to think of. Azure Storage Explorer is also good. It's free tool that you can download, and that is something that you like. That's something you can have locally in your machine, where you can connect to all your Azure storage accounts, and maybe one of them is used for your local dev for a function app, and that is good because you see what's going on in your storage. You don't have to go to the web page of Azure portal to kind of like check what's happening in my instance or my workflows, for example. And then deployment slots is also supported in this. And then for security, since we're doing serverless and we're talking a lot with like endpoints and APIs, I recommend using Azure Key Vault that is protected by Azure policies, locks, or even managed identities for security reasons. And as developers, we try to keep our applications secure by not putting in the connection strings exposed to the public or any applications that might be riskful for us. And error handling, we do the normal way that we do in our C# code. We use try catch block, but specifically for durable functions, or Azure function, you get this like exception called function failed exception. And in order to prevent or to handle that, you can actually, there are several ways. You can do call another activity in your try catch block. You can actually make use of the method. This is in C#. There's a method called call activity with retry async that you can retrieve by the context, durable context, and then durable timer also exists that you can use. And then there's also durable functions monitor for monitoring, and of course app insight. And this is how it looks, the automatic retry. So you have the context, so you have this method, and then you're trying to do a call with this another function. And then in your retry async method, you actually can build your options or configurations for retry. You just need to create an instance of this method called retry options in your orchestrator, and you can choose the interval and the number of attempts. And for this case, in this retry options, you can actually, it's trying to do the interval of 5 seconds and up to 3 times. So when this, it's gonna do that until, and then it continues to the next task that it needs to do in your orchestration. And this is another example of error handling with try catch. So you have a transfer funds, and as you see here in the exception, if something goes wrong, then it's trying to call another activity called credit account, which means it's gonna reverse, return or transfer back the account that didn't went through because of technical error maybe. So that's how you handle it in try catch. And then when it comes to unit testing, you can definitely do that with the normal testing frameworks like Xmock, XUnit. And then you can actually unit test by activity level, orchestration level, or the entire workflow as well. And more information about that in details, how to do it technically, it's also in the durable function docs. And CI/CD for deployment, there you can actually do that. The traditional one, you can host your function app in Windows or Linux, and then function app container, you can also do that. Container registry, and then for workflows, GitHub Actions, of course, DevOps as well. And you can use infrastructure as code with your deployment, and the traditional one, the pub XML as well. I believe this one maybe is not preview anymore. This needs to be removed. But on the recent build, Azure Container Apps become generally available for everyone. And this is for if you want to do serverless containers with support for microservices, Dapper, and also CADA. So you can read more about container apps on this link as well. And this is how it looks right now when it comes to general availability and the roadmap for Azure functions in general. So as far as for those of you that works in .NET, that Azure functions has 2 types. It has the in-process one and isolated process. And we in .NET, we're moving away from the in-process, as you see here. So it's going to be like, since .NET 7, durable functions will be supported. And then so the flow, if you see the one with the thicker circle, that's like the durable functions support. And this one, the isolated process, will continue until .NET 8 when it's coming. And I want to share also about a use case since I'm not able to demo some code right now. I want to share to you about Cloud Katana, which I myself have helped a bit in the creation of this. This is by Roberto Rodriguez, an open source project by Microsoft. And what it does is kind of like uses serverless in PowerShell to simulate attack and defense attack in Azure AD. And this is a good example that Azure Functions can be a security risk, but at the same time, it can also be used to protect our resources in Azure. And this is something I think open source that you can try out for your project. So you can definitely check this out. And I know that Roberto is looking for contributors, and so you can check the contribution guide for that. And my demo, this is what you can do actually with function chaining examples. So I have a blob trigger that kickstarts the orchestration. And then in my orchestration, which uses the function chaining pattern, actually passed in the blob data. And then what I do with that when it comes in, my first activity would be to send that message. I'm creating a queue message to the service bus with the blob information. And then what I do when I receive it in my service bus, it's going to send an email or call using the Twilio service. And then it's going to send an email using SendGrid. So this template or repo is a small example that you can actually check on my GitHub on this link. And you can, I actually created a README file with instructions how you can try it out yourself. So you can definitely use it as template when you create one in your own GitHub. But this is an example where you can really see that durable functions or Azure functions can be used for workflows, not just for Azure services like Azure Service Bus, but also external services like Twilio and SendGrid. So expected results. So I was able to get an SMS. I received that as well on my clock. I got a call, I got an email, and I also, when I received it in my service bus queue container, I also also received an email. And for learning resources, I recommend to follow Azure Functions on Twitter. And I have a good friend, another MVP in Netherlands called Mark Ducker. He talks a lot about Azure Functions in Azure Functions University channel for both beginner and advanced level tutorials. And if you want to find examples, get ideas, there's an Azure Serverless community library as well that you can check where you can clone the repo and get up GitHub projects from the community. And also I wrote an article last year about durable functions, explaining it in details in text. So you can check it out as well. And then another event that I thought that would be useful, it's recorded on YouTube. The Norwegian.net user group had this talk about event sourcing by Einar Ingebrigtsen. I can't pronounce the correctly maybe, but it's a good. I watch it myself, a recording. I like it because it kind of like it explain event sourcing, and it's kind of related to event-driven development, like what we do with Azure Functions. So check it out if you have time. It's an additional learning to find out. And then if you want to speak in my community, I have Azure User Group Sweden. So, or if you want to join us and listen, feel free to just connect and join us as well. Since we're all community from different parts of the world, please do that. And then finally, I want to say that to conclude as well that as a developer, I love serverless because I can solve complex problems. I can build modern apps, and it makes me productive as a developer. So thank you so much. And if you want to connect or if you have more questions about this topic, feel free to follow me on Twitter or connect on LinkedIn or visit my website or connect. Just connect. Thank you so much.